In this question, it is given that let S equal to set of all values of alpha such that this equation is satisfied. And after you have found the value of alpha, then the maximum value of beta for which this equation has real roots. That is, for all values of alpha which satisfy this, those values will be putting here, and you have to find the maximum value of beta so that the equation has real roots. Is dash, you have to fill in the blank. First of all, as S is set of all values of alpha for which this equation is satisfied, therefore first I simplify this equation. This can be written as log of 9 to the power 2 alpha minus 4 plus 13 upon 5/2 into 3 to the power 2 alpha minus 4 plus 1 is equal to 2. This implies that 3 to the power 4 alpha minus 8 plus 13 upon 5/2 into 3 to the power 2 alpha minus 4 plus 1, and because the base was 2 here, therefore we will be getting 2 to the power 2, that is 4. Now for simplicity, let us name this as t. I get t square plus 13 upon 5/2 t plus 1 equal to 4. That is, I get t square plus 13 is equal to 10t plus 4. That is, I get t square minus 10t plus 9 equal to 0. That is, the roots are t minus 1 into t minus 9, and that is t equal to 1 or 9. That is, I can say 3 to the power 2 alpha minus 4 is equal to 1 or 9. That is 3 to the power 2 alpha minus 4 equal to 3 to the power 0 or 3 square. That is, I can say alpha is equal to 2 or 2 alpha minus 4 equal to 2 implies that alpha is equal to 3. Therefore, the value of sigma alpha becomes 2 plus 3, and this becomes 3 square plus 4 square. Therefore, putting the values of alpha, I get x square minus 2 into sigma alpha means 2 plus 3 whole square x plus sigma alpha plus 1 square means 3 square plus 4 square into beta equal to 0. That is x square minus 50x plus 25 beta equal to 0. And further, we have to find the maximum value of beta so that this equation has real roots. For the roots to be real, d should be greater than equal to 0. That is 50 square minus 4 into 25 beta is greater than equal to 0. That is, beta is less than equal to 2500 by 100. That is, the value of beta is less than equal to 25. Hence, we conclude that maximum value of beta becomes 25. Therefore, the answer to this question is 25.